be demoing MOSFES, which is our tool for visualizing multi-object spectroscopy from JDOST. So MOSFES is, we've built in a lot of different convenience methods for handling JDOST data, but if you have your own MOS data set, you can also load things manually. Today, we're going to be taking a look at a real JDOST observation, specifically from the early release science program 1324, more commonly known as JDOST GLASS. It is an observation of the Able 2744 cluster that was observed in NIRCam, NIRISS, and NIRSpec. This particular demo is going to be looking at specifically the NIRISS wide-field slitless spectroscopy dataset from that observation. If you want to know any more information, there's a link to the dataset right here, as well as some links to our MOSFES and general JDavis documentation in this notebook. Okay, so looks like while I was talking, MOSFES was able to load, but I'll go ahead and talk about what's going on here in this notebook. So first, we're going to go ahead and run our standard imports, nothing too fancy here. And then starting MOSFES is the same as any other configuration in JDavis. All we need to do is create an instance of MOSFES, just like that, and then call mosfes.show. And then I decided to show it in the sidecar over to the right so that we can go ahead and see the Viz tool and the notebook simultaneously. Scrolling down here, we have a link to show downloading our data. Now, because we're here on the platform, we went ahead and preloaded your data onto the platform. So that's what this first cell is here, just pointing to our preloaded data. But in the event that you're looking at this notebook after the fact, or you're looking at it, you're trying to run this on your own outside the platform, you download this notebook, we also include this cell right here in order to download it from the internet. So you can take this notebook and run it outside the platform. Like I said, with MOSFES, we've taken extra care to make sure that we try to make the JDOST experience as seamless as possible. So for the most part, MOSFES knows and understands the specifics of each particular instrument on JDOST. So if we go ahead and call mosfes.loaddata, we can actually provide it a directory, which is that same directory we provided up here. And then all we need to do is tell MOSFES that we are observing we're looking at a NIRISS instrument. So go ahead and just specify instrument equals NIRISS, and then it will take care of all the NIRISS specific parsing that's necessary, and it will go ahead and load your data just like that. Let's go ahead and take a look at what we're seeing here in MOSFES then, shall we? Okay, so MOSFES is one of our more, it was one configuration with a lot of different viewers, so let's go ahead and take this piece by piece. So at the very top of the window, we'll see our image viewer to the left, which is not particularly exciting right now. To the right, you'll see two different spectral viewers. The top one is our 2D spectrum viewer, and the bottom viewer is our 1D spectrum viewer. And then below that, we'll see our table of targets that's loaded into MOSFES. The way that you can quickly look at all the different targets is just by clicking on the table. So if I go ahead and click on one of the rows here, you can see in the upper viewers, they automatically change their view to look at that particular target. So all you need to do is just click around the table and go ahead and explore the data set just by clicking around. Hopefully this tool looks very, very familiar to what we're seeing in SpecViz. We try to make the tools very similar to each other, so when you move from configuration to configuration, from tool to tool, you'll be very, very familiar with all the different ways of navigating around your data set. So similar to your other tools, we have our home zoom on each one of these. We have our zoom options. If we right-click, we have multiple options on how to zoom. We have our pan zoom tools and our subset selection tools as well. One of the things that's cool to see is that as we click around this data set, you'll notice that the image in the left is automatically changing to what we're looking at. If I select the home zoom button on the image viewer, it will zoom out to the full image. MOSFES knows and understands the location of each one of the spectrum, and as we click around in the data set, it will automatically zoom into that particular target for you. So you can see in the context from which you're viewing your spectrum. All right, so going back to what I was saying about linking, you'll notice in the 2D spectrum that we don't actually have an x-axis here. And that's actually for a very particular reason. So linking allows us to tell that certain aspects of the data are equivalent. So in this particular view, our two different spectrums share the same spectral axis or wavelength. So if I go ahead and select the zoom tool on the 2D spectrum, I'm going to go ahead and select the horizontal zoom tool and move back and forth. you'll actually notice that the 1D spectrum moves along as I drag the 2D spectrum. And that's because we have effectively linked those two axes. Same thing if I zoom in as well. If you zoom in on the 2D spectrum, you'll see the 1D spectrum zoom as well. And same thing as well if I decide to zoom instead on the 1D spectrum, the 2D spectrum follows accordingly. So this is a nice demonstration of the power of linking data sets and leveraging Glue on the back end. All right, so that's sort of a brief view here of MOSFET and what you're seeing here. So let's go ahead and do some fun science with it, shall we? So if I scroll down a little bit, we can see a quick preview of the different tasks we'll be performing in today's demonstration. The first thing I'd like us to do is select target 158. So let me go ahead and scroll down to the table viewer. I'll increase the rows per page to 100 just to get more of those targets listed. And scroll down until I find the target with an identifier of 158. And it usually shows up around row 91. Yep, there it is. So I'll click on row 91 and it will select the target with the identifier 158. So the reason why we selected target 158 is because you can actually start to see in the 2D spectrum there are some emission features that are shining brightly in the center of the spectrum. But let's go ahead and try to make that pop out a little bit more, shall we? So similar to any of the other tools, the rightmost button in the viewers is our plot option. So go ahead and click that in the 2D viewer. And it'll automatically pop open our plot options and select our 2D spectrum viewer. If we scroll down, you can see all our usual options of stretch. We have our opacity, contrast, bias, and such. But I'm going to be taking a look at the stretch min and maximum values. And if I change those to something more in line with what I'm seeing, I'll set it to 0 to 20, or even maybe to 15. You can see as we adjust those values, the features start to become a little bit more apparent in the 2D viewer. There's just a quick demo of showing how we can adjust our plot options. I'll go ahead and close the plugin bar. And then I'll also take the vertical zoom. So go to our pan and zoom option in the 1D spectrum. It's like the vertical zoom tool. And I'm using my scroll wheel. I'll zoom in to roughly in the same area as that bright feature. And as we zoom in, we'll actually see those features start to pop up here. All right, and now that we've opened up the plot options, you might have actually seen as we were moving around, I'll collapse the plot options menu here. You can see many of the same options that we saw in SpecViz are also available here in MOSFEZ. We try to make sure that if you have similar data, you can perform similar actions across all of our tools. So the model fitting plugin, line list, line analysis, that is all available here. And that's because we have our 1D spectrum viewer. You can think of this 1D spectrum viewer as effectively an embedded instance of SpecViz, and we can also do here in MOSFEZ. So to sort of demonstrate that, let's try to go through a very similar workflow of trying to identify what these lines are and what the redshift is. So I've given you a little hint here in the text that shows which lines should be visible. So I'm going to go ahead and open up the line list plugin as we did in SpecViz. I'll scroll down and rather than loading our preset line list, go ahead and open our custom line list instead so I can put in my own custom lines. I'll go ahead and copy the information that's in the notebook. So we'll add H beta first, and this is at a rest wavelength of 4,861 angstroms. We'll add that, and we can see now we have H beta listed here. I'll do the same thing with O3. I'll type O3 and change that rest value instead to 5,007. We can see it's now added down here. If we go to our 1D spectrum viewer, we won't see any lines just yet, but we will see that same indicator here that's showing that we have two spectral lines over to the left side, which indicates that we are highly redshifted. I'm going to go ahead and just give us a little bit more view by selecting the horizontal zoom tool in the 1D spectrum viewer and zooming in just a little bit here. And now that we have these two lines, I'll scroll up to our redshift slider. And then we can, similar to we do in SpecViz, drag this slider across. And if we do that a couple times over to the right, hopefully we should be able to see those lines come to view eventually. It might take a little bit here. And as we get closer to a redshift around 1, we start to see those lines start to show up here. We can use the slider to try and take a guess at where the redshift is, and that looks just about right, just around 1.3. Now, one thing you might have noticed as we were adjusting the redshift, you go down to the table viewer, you'll actually see a new redshift column has popped up in the table viewer and has actually saved our redshift value that we've added. And one of the great powers of working with JDViz inside a Jupyter Notebook is, of course, the ability to pull out the data that you've worked in the notebook. So let's just say you wanted to pull out that redshift value and do some additional analysis in the notebook. If we come back to the notebook side, we can use the API to actually get out that redshift. So we ask MOSFiz to get a column and provide it the redshift. You can go and execute the cell, and it will retrieve all the redshift values in MOSFiz. Now, of course, there are lots of different targets here. So you can see that there are a lot of zeros, but you can see embedded in the middle right here, our redshift 1.3 is saved right here in the column. And if we know that this is on row 91, if we can do some Python magic to slice and ask it for only the 91st entry, and if I execute that instead, we can see the redshift value popped up right here. All right, so from here, that was just a quick demo of how to get out the redshift, but not only that, we can also change the redshift as well. So let's just go back to our redshift slider here. I'm going to move it intentionally off of the 1D spectrum. So just move those lines over to the left a little bit so those are not aligned. Now, to run this demo, if your target happens to line up at a different row, then go ahead and adjust this value accordingly. But mine is on the 91st row, so go ahead and execute that to say we're modifying the 91st entry. And I'll ask MOSFiz to update our column. We'll say update the redshift of row 91 to 1.3, and if I execute this cell, if you take a look at the 1D spectrum viewer, you can see those lines automatically jump back into place. It returns back from that cell all the different redshifts, and you see it's now adjusted to 1.3, and then also our redshift in the column has updated as well. So from there, not only do we have a redshift column, we can actually add any number of columns to the table viewer. This table is yours to adjust to your liking, whatever works with your science workflow. I'm actually going to collapse the plugin tray up here. So let's say you were taking a look at a bunch of these targets, you want to take some notes in it or flag some of the targets. So let's just say for this particular target, I think it looks really, really cool. So I'm going to go ahead and add a new column and just call it notes. And then I'll update that column, and then just add a note to that same row to say, hey, I think this target looks really, really cool. So if I execute the cell in just a moment, MOSFiz should add in a new column to the table viewer as it does. And you can see right here, my new notes for this one target has shown up. So this is a great way as you're scanning through all these different targets to flag them, be like, hey, there's something interesting here, or there's a particular feature in this particular spectrum. MOSFiz provides a great way to quickly just look through a bunch of different targets. Now, as we're going through and looking at all these different spectrum, all these different targets, things can absolutely get very messy. So if we have a lot of these notes and you don't need those anymore, you can hide those by calling MOSFiz.hide column and just say which column you want to hide. In this case, I'm going to go ahead the notes column here. So if I execute this cell, you can see our notes column has disappeared and things have returned back to normal. So that was a very brief whirlwind tour of MOSFiz. Hopefully, you can start to see the power of JDViz and all the different ways that we have built in the different functionalities to be cross-compatible and cross-functional between the different configurations. And as you start to explore more and more JDViz data and looking at it through all these different configurations, you will hopefully be very familiar and very comfortable in between each of the tools. So yes, MOSFiz is a great particular example of doing a very quick look at a lot of different spectrum very, very quickly. But let's just say in this particular example, this particular target 158, this looks really, really cool, and you wanted to do some additional analysis on it. So if we go into the notebook cell, we'll actually do something pretty cool here, which is we can go ahead and pull out our data. So we ask MOSFiz to get data from viewer, and we'll provide it our 2D spectrum. And then we also provided the data label. If I open up the data the data drop down here, you can see what the name of this data set in the 2D spectrum is. If we copy this and add it to the data label, we can actually extract out our 2D spectrum. And this is a great time to introduce our next configuration, which is SpecVis2D, a visualization tool specifically designed for 2D spectrum. So by pulling out this 2D spectrum, creating an instance of SpecVis2D, and then asking SpecVis2D to load that 2D spectrum, want to execute this cell, you should see our new configuration with that same spectrum plotted right here. And this provides some additional analysis features for your 2D spectrum. All right, fantastic. I think that brings us to the end of our MOSFES demo.